What's up, guys? Welcome back to the Vertical Intelligence Insight Hub interviews. Today I'm here with Enoch. He's one of my classmates and friends. He's like one of the smartest people I've worked with. He's incredibly knowledgeable about machine learning, artificial intelligence. Do you want to give yourself an introduction, Enoch?
Sure. I'm Enoch. I'm a freshman at CAS at NYU, majoring in honors math and computer science, and I'm very interested about general AI. Um, it's like, yeah, we knew each other from last semester business analytics club in Stern, machine learning team. Yeah, so we knew each other.
Yeah. We were
Really
both part of this
different.
machine learning. Sorry, go ahead. Yeah.
Yeah.
Okay, yeah. Yeah. Since like, what made you interested in artificial intelligence and machine learning in the first place?
Well, I guess in the first place I was more interested in reinforcement learning because I was like when I was small I was interested in self-driving cars that when I was like 10 years old. I had this vision when we won't need drivers anymore, and all cars would be controlled by like a supercomputer in the city, and there would be optimized traffic. There would be no more traffic distance, stuff like that. Um, yeah, so that's what really sparked my interest in like this field in general. Um, but then like everyone knows, a few years ago, ChatGPT came into existence like around 2 years ago. It blew everyone's expectations, and it became, the most powerful topic right now. Um, yeah.
No, I see. I see. Okay, yeah. So, did you study reinforcement learning at all? Like, is that how you started, or were you just like interested in that field in general?
Um, when I started, I didn't have, a lot of the necessary background to get started in, like actually hands-on machine learning. But is now like, after learning all the basic like math concepts and stuff, like I guess I'm ready to like dive more deeply into reinforcement learning and explore how the model really works instead of having this thought about it. Yes.
Yeah, that's true. Yeah, like backprop and stuff all needs like complex
True,
calculus solver.
true.
Yeah,
It's Just to really understand machine learning, you don't really need that much like mathematical maturity. I guess like basic vector calculus and then algebra should be enough to get you through neural networks. But if you really want to do like research in um like learning theory, or like the more deep aspects of machine learning, then you definitely need stuff like probability, optimization, stuff like that, differential equations.
right. Wait. Yeah. Is like current self-driving software, is it trained on neural networks or reinforcement learning, or like a mix of both? Do you know?
Mm, Honestly, I guess it's more closer to like multi-agent reinforcement learning because basically you'll have a like like for the self-driving cars, you would have a scenario where each car would be an agent, and you have like tens of thousands of them in a city, and then they would learn how to interact with each other, and how like if you're gonna get from point A to point B, you'll learn how to plan the course efficiently so it doesn't like crash into other cars and stuff. I guess in that aspects, it's more closer. It has more to do with reinforcement learning.
Oh, okay, I see. Well, yeah. So like each individual car is communicating with other cars.
Yeah,
So there's like a network of communication that's also going on in the background.
sure. Because um or the cars could communicate with each other, or they could just send their data to like a central data processing center, and the processor would send them instructions back. I mean, that's kind of like how it's kind of like two aspects of how it works. You can communicate with each other, or you can have just a giant computer do the stuff for you. But I guess I guess for the second situation, there wouldn't be there like currently there isn't any like supercomputer that's powerful enough to handle all all the requests from every single car.
Right,
That's
that's
what,
true. Yeah, like I would assume it will also be like localized, right? Like
yeah,
you'll will only be like communicating with cars around you. Yeah.
yeah.
Otherwise, it'd be too much.
That's
Yeah.
kind of what we're getting into right now.
Yeah, that would be cool. I mean, just like from what I've seen, like I still think there's like some neural networks involved, right? Like, have you heard about like the YOLO algorithm or something? For
Yeah,
like, yeah,
neural networks is
like
really
for
kind of the core of
CNNs.
machine learning. You couldn't really get
Yeah,
too far without it. So yeah.
yeah, that's true. Yeah. Okay, yeah. What projects have you been working on or like have worked on? Do you want to talk about it?
Sure. I mean, last semester, I was in the machine learning team at BAC at Stern. So what I did for my project was, uh, stock prediction using using news article headlines. So basically, in theory, it would take in news headlines as an input and spit out um, a one or zero, depending on whether it would predict the stock market to go up or down. Um, yeah. So the data I trained it on was, like the past 10 years, the top 15 headlines for every day, and its corresponding, like stock market movement. So. Because in that aspect, I trained it more like a classification task. You would have in basic text classification, you would have um a bunch of words or sentences, and you would want to attach like sentiment label or like if you want to classify news, for example, you would attach
Right.
like sports, something like that. But yeah, so that's basically what I did. Uh, the tokenizer I used was BERT for sequence classification. Uh, so again, it's more like a classification instead of a time series analysis.
Mhm.
Mm, but I think it turned out to be pretty well at the end. After like 10 epochs, I had a pretty good accuracy, F1 score, all that stuff. Yeah.
What was the accuracy, if you remembered?
It was like 90 something, like 95. I can't remember the exact details, but it was,
That's
yeah.
very high, man. That's very,
But it
very
could
high.
be
Yeah,
overfitting.
yeah.
That's what I'm worried about. Yeah.
Yeah, yeah.
Yeah.
Okay, so this so that would mean like if I get the if I get the headlines for today, right, and I put it into your model, like let's just say the 90% wasn't overfitted. That would mean it would be correct 90% of the time. So like if it tells me to buy the stock, that means 9 out of 10 times the
I
stock
mean,
market would
not
actually go
necessarily.
up for that day.
Not necessarily. The data, like the stock movement price I train on was based on the Dow Jones average. So if this actually works, it would tell you it would tell you the state of the whole market. It'll go up or down
Uh,
and not like individual stocks. Because um when I first started, I wanted to do like individual stocks. That's more uh you know and tell you whether to buy the stock or not, whether the stock will go up or down. But that's there's so many stocks in the world that it would just be the data set would just be too large. So I decided to train it on like a more general version of stocks, which is the Dow Jones average in the end.
right. Did you try to back test it at all?
Um, yeah. So I split the data into like 70% used for training, and 30% rest is used for testing. So the testing accuracy was around, I can't remember, it was around 70%. I mean,
Okay.
think it still could be improved, but it's like that's better. You want to prove that it's better than nothing, right? So if it's better than 50%, it's doing something at least.
Yeah, yeah, yeah. Well, did you try to like? Did you try to like for the test set, right? Did you also try to
Mhm.
like, put it into like a backtest machine? So like, you would in like when the model says buy, you would buy, and like, did you see what return you got, or is that like a next step?
That's kind of a next step, I think,
That
because
would be interesting to see.
yeah, there's no really like specific stock that is included in the model is, as I've said, is just the Dow Jones average and tells you whether the whole market will move up and down. If you want to target a specific stock, then I would guess you need a data set um, with you know like all the news headlines that includes the company's name, I guess. Yeah.
Well,
But
I mean, yeah.
yeah,
Well, there's probably like ETFs that like follow the Dow, right? Like
true.
Dow Jones the index, but like there's probably like many those ETFs that match that.
Mm, yeah. Yeah, I guess.
Yeah. Okay.
Mhm.
That's cool.
That would also be a use case, I guess.
Sure.
Yeah.
How long did it take to train like everything?
I mean, the actual training part, I just trained for like 10 epochs. That was you know, like it was close to 30 minutes per epoch. So that was like 5 hours in total. Just ran it for the night. Yeah.
Okay, I see. How many you said it's 10 years of data, right? Like us.
Yeah.
So how exactly is the data structured? Is it like just each there's like 15 columns and then each column would have one string uh which is a news article?
Well, it when I downloaded the data set, it came in that format, but I just reformatted it to be like just two columns. One column is the label, like
Oh, I see.
whether at the end of the day it'll go up or down, and the second label is the string headline. Yeah.
Got it. Yeah, yeah. Okay. And that's like before you train it, you first tokenize everything, right?
Yeah.
Yeah. Oh, yeah. Okay. You want to explain like what is tokenization? Because some people might not understand that.
I mean tokenization, I mean, you could basically just interpret it as a machine learning algorithm taking a word and sometimes it will split it, sometimes it will not, but most of the time it would just put that word and it would project that word. It would take in this word and give it a set of numbers, basically.
Okay,
Yeah.
got it. Right. It's like big. It's like similar to embeddings, right? Like word
Yeah.
embeddings. So like the
Yeah.
vector would be like a numerical definition of the word, right? So like
Yeah.
the machine can actually
We'll
because
just
the
take
machine
this
can only
word
understand
and
numbers.
yeah, and interpret it as a number. That's what
Right.
basically is. Yeah.
Yeah. That's cool, man. Yeah. Uh, yeah. Like, how did you initially learn machine learning and AI?
Uh, I guess machine learning. There's a lot of you know like videos on YouTube around this topic in general, but when I first learned it, it was using Andrew's course on machine learning. I think
Yeah.
basically everyone has learned about that course or
Yeah.
has
Same.
watched
Same.
it.
I did that
Yeah,
as well.
the one on Coursera. I guess that just really just gets you into the door, but it doesn't cover really anything in depth. So, I mean, if you just want to learn what machine learning is and you know how it's applied, then I guess that course will be enough. But you wanna like really get into research, then you definitely need a lot more stuff than that. Yeah.
Yeah. Well, what are you doing now to learn?
Um, no, I'm mostly interested in like learning theory or like learning theory basically you know the you investigate what this model really does each step. So
Mhm.
you know like before people thought of machine learning as a black box because they couldn't really understand what was going on inside the model. They would just know that you know it does this, it does that. But what learning theory does is that it goes into the model and analyzes it like what steps it takes to get to the results. So I'm currently learning probability and optimization. I guess that's two most important things about learning theory. There is also a really nice book. What's called? Uh, but it's by Francis Bach. He's a French computer scientist, and he has an amazing book about learning theory.
Okay, I see. Oh well, like isn't isn't what you're talking about like what goes on within the model, right? Isn't that just forward propagation, or are you trying like right, or uh, or are you trying to like go like a layer beneath that? If you want to explain more about learning theory.
Uh, I'm also just getting into it, so I don't understand that much.
Okay.
But
Uh,
I guess like in more sophisticated models, there's a lot more going on under it. I mean, if you're just training like a basic like classification neural network or like a then you probably just need basic neural networks. But for other like machine learning use cases, then you do need more sophisticated like algorithms and architectures to really get to what you're doing. Yeah.
yeah, that's true. I recently learned this new algorithm for like machine translation. It's called beam search. I'm not sure if you know it.
Oh, no, no,
Oh, yeah, like this algorithm is basically like when you use like transformers and stuff,
yeah,
or like RNNs to generate like machine translations, right? You first have an encoder and then the decoder actually generates the words. Like you can't just take a greedy search because like you can't just take like a random sample because otherwise you might not actually get the best translation because it's like a random sample, right? But then
mm,
at the same time, you don't want to just take a greedy search, which means like for every word, just take the highest probability because what might be the best starting word might lead to worse like words down the line, and that wouldn't actually be the best translation of the sentence as
yeah,
a whole.
yeah,
So you
that's
want
true.
to take the highest probability sentence. So what beam search does is like you have a beam parameter, for example, 3, and then like it uses that parameter to like find to try to approximate basically the highest probability sentence given the translation. So if you have like I have a dog, it's not just getting the highest word one after another, it's getting like the best translation of I have a dog, for example, in Spanish of the whole thing. Yeah. So
Mm.
that was
So
pretty interesting. Yeah.
basically you're looking at it as a set or like a sentence.
Yeah, yeah,
Or
yeah,
more like
exactly.
a set of words instead of an individual word. So,
Right. Yeah. Yeah. So like you're kind of trying to study these kind of algorithms. Is that something like that?
sure. That may be one like application of learning theory where where it comes into focus. Yeah.
Yeah. Uh where do you see yourself like in the machine learning field in the next 5 to 10 years? And what do you hope to be working on?
Uh, mm, it's obvious that machine learning is developing real fast. You know, it's a real popular field right now, and I'm sure that people will do much more with machine learning in the next 5 to 10 years. Uh, so. Mm, right now, my current aspiration is to do like a machine learning PhD and really contribute to the community because it really is one of the most exciting things happening right now in the world. So uh, I would think of machine learning as more of a tool rather than like a solution to everything. Um, like people would say that machine learning would take over everything. It would they would completely innovate every sector. I think that's not entirely possible. Machine learning certainly is very promising, and but mm, but in the end, it's still a tool, and the tool will only find its best use case in hands of the person who knows how to use it. So yeah, I guess my goal is to become the kind of person.
I agree. I agree. Yeah. I feel like people are saying that because they think like, okay, AGI is going to be developed or something. Like, I feel like if suddenly AI does become conscious or like like self-conscious, then that would like change everything. But just based on like what I've learned right now, like all of these models are based on statistics. So I think like in the next decade at least, I don't think that's going to happen.
All machine learning right now is based on numbers and algorithms. So
Yeah. I don't
as
know, bro. Like, if they get some like, have you seen the research recently? Like, where they like taught like brain cells, like literal brain cells, how to play Pong.
I've seen research like that. Like
Yeah, like if they manage to get these brain cells like do AI stuff, then I don't know, man. Like, It
Hmm.
could change really quickly.
I mean, but for now, I guess the goal is really to build, like interpretable and generalizable like models.
Right.
That's what we're focusing on right now because still people don't like researchers right now don't understand everything like in what's going on in modern machine learning. So you know, it really needs to be interpretable and generalizable for it to really make an impact.
Yeah, it's gonna be like a long way before you actually get your PhD, but like I don't know, like do you have any ideas right now of like what would you be interested in researching? Like model interpretability? Yeah. Any broad
Uh,
ideas? Because I'm just kind of
Broad
curious.
ideas. I mean, there's a lot of ideas. There's a lot of ideas that I'm interested in exploring right now. But like learning theory for one. Um, because it is what learning theory is trying to explain how these models work and try to come up with new algorithms to align my thoughts of machine learning being understandable.
Right, right. Okay. Cool, man. Um, yeah, okay, just like based on this, right? Which AI verticals do you think like these machine learning models will be most useful for? Like ed tech, uh, healthcare, or like supply chain logistics? Have you do you got any ideas, bro? Any visions? Any dreams that any like prophecies that you
Mm,
got in your sleep about it?
I mean, well, I tend to think of machine learning as, a model that's built upon data. So for anything to be for anything to have an application for machine learning, it has to have, huge amount of data for it to work, right? So out of those that you mentioned, I guess like supply chain would be a very promising aspect. They're just supply chain is all about statistics and operation
Yeah,
management and and optimization. And I think that's what machine learning is also good at, optimizing something based on data, because you can just simply because it can auto tune the parameters. Um, other than that, I'm not really an expert in like in like medicine or like biology and stuff, so I can comment on that.
yeah. Me neither. I mean, like one area that I'm like really interested in is like the intersection between machine learning and robotics. Because like if we can have these LL if we can have these models basically generate a bunch of words, right? LLMs, like why
Yeah,
can't we train it on human motion and get it to generate human like motion in the future? Like if we can combine like the hardware that we have now in robotics and then also like some type of model that generates motion, so software, and we combine those, then I think that could be very powerful in the future.
yeah. Yeah. There's a couple of people working on it in CS right now. Yeah. Like the intersection between robotics and machine learning. I guess computer vision is also,
Yeah.
a huge field, especially it's because it's just so related to robotics in general. Yeah,
Yeah,
but
well, I mean, like self-driving cars is like a lot of it is computer vision, I would say.
yeah,
So we've made a lot of progress there.
yeah, that's a lot of fun. Yeah, that's lots of vision.
Yeah. What has been the most challenging parts for you when studying ML, like other than the math that we talked about?
Uh, hmm, what challenging aspect? Uh, I guess like right now. It would be trying to understand what's happening at the frontier of AI, of AI research, because you really do need to build a very strong foundation in math. I know it doesn't include math, um, but it is the most important part. Well, when you're learning about AI, in my opinion, 'cause if you don't, if you if you don't understand what's going on, then you're never going to come up with your own novel aspect or like your own novel uh vision of what you want to do. So mm, I guess yeah, it's probably but it's the same for every field. So you want to if you want to do like high-end research, cutting edge research, then you have to go from the ground up and try to build a solid foundation before you even attempt these kind of things. And that's uh what I'm doing right now. But
Right,
it
right.
is very
I agree. Yeah, like if you want to make any innovation, like you have to think from first principles, right? And like
yeah.
mathematics is the first principle of many things.
Of mathematics, I guess it's the first principle of every science right now,
Right. Yeah.
almost every
Yeah.
science.
Exactly.
Mhm.
Yeah. Okay. I guess for people who are just like getting started in machine learning or like people who want to start, do you have any advice to them? Yeah.
Mm, like as I've said, just start with the basics. Uh, basic programming, basic math, basic stats. We really don't need that much high-end high-end stuff to get you started. Try to build your own neural network from scratch, see how that turns out. But uh, but what happened to me was I tried to focus on like very low level, not a level, but very basic math at the start, but I guess for some people you could really burn out and lose motivation of why you're doing all this stuff in the beginning to work with. So I guess to make yourself motivated, you have to have a really concrete problem of what you want to solve using machine learning. Because if you say if you just think machine learning is popular right now, it's I want to get a job in AI, I want to be an ML engineer, then uh you really don't have any motivation to learn all this stuff. Um like yeah, so try to think of a problem that you're really passionate about that you think can have applications in machine learning. For example, for me, it was self-driving cars, uh, and that would motivate you along your journey, I guess.
Yeah, I agree. I agree. Definitely. Like, like just adding on to that, I would probably say like try to balance the math and the project side of things as well. Because I kind of like burned out as well, like learning so much of the theory, the math behind it. Like I'm learning so much, but like I'm not actually implementing it. So I've been just like working on some personal projects on the side, and like that's given me a lot more motivation because like now I can like actually apply the theories into like building real things, and like I see like okay, I built this project, and this thing actually works, and that gives me like more motivation to learn about the theory and concepts behind it more.
Yeah, yeah. I would say community is also important. Is to try to join a community like club, or have a group of friends who are willing to learn and who are all interested in machine learning. Yes, and that would also be a source of motivation. Or join like a reading group, where you like go over like novel papers, like yeah, public papers in the field. That would
Okay,
also
yeah, sounds good,
help.
man. Yeah.
Yeah,
Thanks, Enoch, for like taking out your time out of your day and like
I think.
going on this interview with me. Yeah. Is there anything else that you want to say to the audience or?
I mean, I think. Uh, see, the mentality of machine learning being a model that that is based on data really helped me a lot. It's not some kind of magic that a lot of people think it is. Right now a lot of like business leaders, like people who really don't understand what's going on, they think that it's magic. You're having conversations with an AI or something. But if you go down to heart of it, it's really just data. Yeah.
Right, right. Yep. Yeah. Okay. Thank you. All right.
Thank you.